In this lesson, we're going to talk about operations with polynomials. And the operations are kind of the basic ones. So we're talking about adding polynomials, subtracting polynomials, multiplying polynomials. And in the long run, we will talk about dividing polynomials, but that's going to come a couple chapters later. And the other thing that we have to refresh our memories on are our exponent rules. Okay, so there's some definitions that we got to make sure that we understand. Monomial, binomial, for example. Trinomial and polynomial. And again, these should all be reviewed. Pretty much this whole lesson is about review stuff, but we just got to make sure we can clean this up. This whole chapter is about dealing with polynomials, and we're going to hit factoring pretty hard, which I guess would be kind of like the division of polynomials. So here's some of the exponent rules that you should remember. The product of powers here is when you're multiplying like bases, you add the exponents together. Power of a power, when you're raising an exponent or a monomial to an exponent, you multiply the exponents. Power of a product, all that says is that everything inside the parentheses gets raised to the exponent, including any real number that's in there. And the power of a quotient, I'm going to handwrite this one. Right, so a divided by b to the m would be a to the m over b to the m. Right, so again, it's very similar to the power of a product. Everything that's inside of the parentheses is going to be raised to that exponent. So that's what's going on here. The final three rules that we'll talk about with exponents is the quotient of powers. So when you're dividing like bases, you subtract the exponents. Anytime anything is raised to the zero power, it becomes 1. And negative exponents kind of flip the part that it's connected to, the base of the term, down into the denominator if it starts in the numerator. And remember, this is, anything is always over 1. So it's in the numerator unless it looks like it's in the denominator. So I would say that this is in a numerator. So the negative exponent drops it into the denominator. Of course, if it's already in the denominator, a negative exponent will pop it up into the numerator. And after it makes its move, it is no longer negative. Now these last two are really fairly simple until you start adding more bases and more parts to the monomial that you're dealing with. And when parentheses are involved, that makes a lot of a difference. Okay, and really all of these exponent rules could show up into one problem, and so you have to really take your time and look at what you're dealing with before you attack it. I'm going to run through some examples of dealing with exponents. Feel free to pause this at any time. Try them out on your own. Again, this should be review. So this first one here, we're going to, you're kind of doing two individual problems because you do have to multiply the 6 into 3 like you normally would. So that would give you 18. And now we're multiplying the x's together. Multiplying like bases, that means add the exponents together. And so you get x to the 7th. Okay, here's another multiplication problem. And again, you're kind of just looking for like bases here. So the only thing that can get together here, the x to the 3rd times x to the 7th. We're multiplying like bases, so that would be x to the 10th. And then we're going to move to the y's. So y to the 4th times y to the 6th, right? Multiplying like bases. So that means we add the exponents. So y to the 10th, and then z to the 0. Now this isn't simplified because you never want to leave anything with an exponent of 0 because that becomes 1. So the final answer on this one would be x to the 10th, y to the 10th. Okay, this third one is we're dividing like bases. Both of them are x's. So that means we subtract the exponents. So we have another division problem, and they start getting bigger and bigger, but you're really just breaking this down into like bases. So if you want to, you can kind of separate these things into three little problems. So you think about just your coefficients. So 45 over 5, it's just a division problem, so that becomes 9. Now we are dividing like bases, so that means we subtract the exponents. Whenever you do the exponent rules, the result ends up in the numerator. And again, remember what I said earlier, if you don't see it in a denominator, that means it is in the numerator. Okay, now we have like bases. Remember, just because there's no exponent here doesn't mean there isn't one. There is a 1 there. It's just understood to be there. So y to the 5th over y is y to the 4th. All right, moving on to these other two examples. This is a very important thing to understand here. The rule says that anything that has a 0 exponent becomes 1. But one of the main things that you have to understand is what is the base and what is not the base. Okay, these are two different problems. The first one ends up being actually -1 because this negative sign is not part of the base. However, when we get down here, the negative sign is inside the parentheses. No parentheses here, but inside the parentheses here. So the whole thing becomes 1. So this is a very important concept, and very important. Parentheses make a big, big deal, so you really have to watch out for them. Okay, so here we have a bunch of monomials that have negative exponents. And the negative exponent by itself isn't really hard to deal with, right? In this first one, just a to the -3rd means that it just shifts to the other part of the fraction. Again, everything is always over 1. So if it's not in the denominator, that means it's in the numerator. So this becomes 1 over a to the 3rd. Okay, likewise, this next problem, right, we have a denominator. The base of the denominator is raised to the -3rd, so that shifts it up into the numerator, 5 to the 3rd. And you can simplify that to 125. Okay, now, the main thing that you have to worry about for when you're dealing with negative exponents is what is and what is not the base of the exponent. In this situation, 4 is raised to the +1. Okay, you don't see it, but it's there. There's no parentheses around all of this. So the only thing that's affected by the -3 is the x. So this becomes 4 over x cubed. So on this next one, the only thing being affected by a negative exponent is the a. So if it is a positive exponent, you leave it alone. So we're going to leave the 5b to the 4th in the numerator and then drop the a down. And again, when you move it, it becomes positive. In this next example, the 3x to the 5th in the numerator, they have positive exponents. Again, that's 3 to the 1st, x to the +5th. So the only thing that we're really messing with is the z. It drops down. There's something left over. It should be a 1. And then it's 3x to the 5th, z to the 4th. On this final one, the only base that isn't moving is the y. It's the only one with a positive exponent. So the z is going to move up top and the x is going to move down bottom. So you would have y to the 7th, z to the 4th over x squared. So here's a couple examples of powers to a power. So in this first one, right, we're raising x to the 4th to the 3rd power. So we need to multiply the exponents. This becomes x to the 12th. I wouldn't worry, on this next example, don't worry about the negative exponents until the end. because when we multiply two negatives together, we get a positive, so this becomes t to the 40th. Make sure you understand that anything inside the parentheses gets affected by whatever the exponent is. So not only the x and y get raised to the second power, but also the 6. Everything has an exponent of 1. So this becomes 6 squared, x squared, y squared, and that would become 36, x squared, y squared. This one would be x to the 15th, y to the 5th. Now, just like everything else we've been talking about, this 5, you have to understand what is and what is not connected to the exponents. This 5 is out in front, not being affected by this negative 7 exponent. So it's just going to be 5, x to the negative 14th, y to the negative 14th. We're not allowed to say we're simplified until we deal with negative exponents. So you don't want to leave any zero exponents or any negative exponents. So our final answer here will be 5 over x to the 14th, y to the 14th. For our two final examples, I picked a couple that usually people get a little intimidated by, but there's only so many exponent rules, and you just have to look at a bigger exponent problem and figure out a way to break it down into several small problems. So I'm going to look at this first example, and we're just going to deal with the left part of it first. So we're raising a power to a power, so that means we multiply our exponents, and then we're going to do the same with these exponents. So our first step, and I would write out these. Don't try to do these in your head all in one step. Write them out. So this should be x to the 6th, y to the negative 9th, times x to the negative 8th, y to the 2nd. Okay, so we kind of just did two problems, but we're not done because now we're going to multiply like bases together. That means we're going to add the exponent. So give yourself a second when you're doing a big problem to regroup and think about what the next step should be. So this is going to give us x to the negative 2nd. Let me do that in the same color there so we can keep it straight. X to the negative 2nd, y to the negative 7th. And like I just said, you don't want to leave your answer with negative exponents. That is not simplified. So both of these are going to move down. You're left with a 1 in the numerator. And now you are done. Okay, so for this last example, again, it looks very intimidating. You got a lot of stuff going on inside, and you got to raise it to a power. But do one thing at a time. You can start by multiplying every exponent by the outside exponent. That would be a fine step, and then dealing with like bases. But I found that it's easier to deal with the inside first if you can. So we'll come back and deal with this power of 3 here in a second. So the first thing it's going to end up being, and I'm going to write it down here so I can keep a little room, is 2. There's nothing to do with the x cubed inside, so we'll leave that alone. But we do have y to the negative 2nd over y to the negative 3rd. If we are dividing like bases, that means we subtract the exponents. And now since we have negative exponents, be very, very careful. This is negative 2 minus a negative 3, so that becomes y to the 1st, all over 3. And we're still raising that to the 3rd power. And so now we're going to distribute kind of the exponents together. Don't forget that there is an exponent of 1 with a 2 and an exponent of 1 with a 3. So then it would be 2 to the 3rd, x to the 9th. We're multiplying exponents, y to the 3rd over 3 to the 3rd. And you can simplify that a little bit further. 2 to the 3rd is 8, x to the 9th, y cubed over 3 to the 3rd is 27. We can't reduce that any further, so that would be our answer on that one.